For question 1a, the question is what is the difference between a null hypothesis, H known, and an alternative hypothesis, HA, 4 marks. For null hypothesis, H known, null hypothesis represent no effect or no difference, but alternative hypothesis represent a specific effect or difference. Second one, null hypothesis assumed to be true by default, but alternative hypothesis contradicts the null hypothesis. The third one is null hypothesis denoted by H known in statistical notation, but alternative hypothesis denoted by H1 in statistical notations. The last one, null hypothesis, researchers test against H known to look for evidence to reject it in favor of the alternative hypothesis. But for alternative hypothesis, researchers aim to support HA by providing evidence against the null hypothesis. For question 1b, what is the difference between one-tailed test and two-tailed test? Also 4 marks. For one-tailed test, direction of one-tailed test examines the hypothesis is only one direction, either greater than or less than. For two-tailed test, two-tailed test examine the hypothesis in both directions, both greater than and less than. For hypothesis, one-tailed test involve the formulation of a null hypothesis, H known, and an alternative hypothesis, HA, in a way that considers only one extreme end of the distribution. For two-tailed test, the hypothesis it involves the formulation of a null hypothesis, H known, assuming no effect and an alternative hypothesis, HA, suggesting a specific effect regardless of direction. For critical region, one-tailed test, where extreme sample values lead to the rejection of H known, is located on one side of the sampling distribution curve. For two-tailed test, the critical region is divided into two parts. Both parts tail of the sampling distribution curve, considering extreme values in both directions. For example of one-tailed test, H known the mean is less than and equal to 23, and HA is the mean is the more than 23. But for two-tailed test, the example is H known the mean is equal to 23, but HA the mean is not equal to 23. The difference is the signs. For question 1c, what is meant by a p-value? 2 marks. The p-value is measure used in statistics to determine the probability of obtaining result as extreme or more extreme than what was observed. Assuming that there is no real effects, a smaller p-value suggests stronger evidence against the null hypothesis, supporting the presence of a real effects. A large p-value indicates that the observed results are likely due to change, and the null hypothesis is retained. For question 1d, a hypothesis regarding the weight of newborn infants at Jitra Hospital is that the mean is 6.6 pounds. A sample of 7 infants is randomly selected, and their weight at birth are recorded as 9.0, 7.3, 6.0, 8.8, 6.8, 8.4, and 6.6 pounds. What is the decision for a statistical significant change in average weight at birth at the 5% level of significance? 6 marks. Okay, to solve this question, we must calculate the sample mean and sample standard deviation first. For sample mean, we plus all the significant and we divide by 7, we get 7.6 pounds. And then we calculate the sample standard deviations and we get 1.09 pounds. For this question, we have 5 steps. Step 1, we write the H known, the mean is equal to 6.6, and H1, the mean is not equal to 6.6. Step 2, we must write the significant level, 5%, we get 0.05. And then step 3, we must use the t distributions. After we use the t distribution, we move to step 4. Reject H known if calculated t less than negative 2.447 and reject H known if calculated t more than 2.447. The 2.447 we get when we use the t distribution. We go to the bell shapes, negative 2.447 at the left side and 2.447 at the right side are area of rejection. So we move to the t. T sample mean minus population mean divide by sample standard deviation divide square root of sample size. We get t equal to 2.427. Step 5. 2.427 is outside the rejection area. H known is not rejected. We can conclude that the mean is statistically significant change in the area weight of newborn infant at Jitra Hospital.
Question number 2A. List the 5 steps to perform hypothesis testing. Step 1. State the null and alternative hypothesis. Step 2. State the level of significance, which is alpha. Step 3. Identify the test statistic, either Z or T distribution. Step 4. State the decision rule. Reject H null if calculated T more than critical T or calculated T less than negative critical T. Step 5. Calculate the value, the test statistic, and make a decision, which is do not reject H null or reject H null. Next, question 2B. Step 1. State H null and H1. Step 2. State the alpha, which is 0.10. Step 3. Use Z distribution. Step 4. Reject H null if calculated Z more than 1.64, and do not reject H null if calculated Z less than 1.64. So we can get the value of 1.64 from the Z table. Next, we find P1 equal to S1 divided by N1. So P1, for P1 we get 0.27 and P2 0.3. PC equal to S1 PC equal to S1 plus S2 divided by N1 plus N2. So for PC we get 0.29. Next, we use the Z formula, which is P1 minus P2 divided by square root PC 1 tolak PC 1 minus PC divide N1 and plus PC 1 minus PC divide by N2. So we can get negative 1.51. So step 5, we conclude negative 1.51 falls outside the rejection area. H null is not rejected. We can conclude that there is no difference in seatbelt between 25 to 34 years old and 45 to 64 years old. Next, question 2C. Step 1, state the H null, which is mean more than equal to 6. H1 mean less than 6. Step 2, state the alpha, which is 0.01. Step 3, use T distribution. Step 4, reject H null if calculated T less than negative 2.998, and do not reject H null if calculated T more than 2.998. So we can get the value of 2.998 in the T table. Next, we use the T formula, which is S bar minus mean divided by sigma over square root n. So we can get the answer, which is negative 1.64. So step 5, we conclude that negative 1.64 is outside the rejection area. H null is not rejected, and we can conclude that the mean rate of return is more than 6%. Question number 2D. Step 1, state the H null, mean fast food less than equal to mean restaurant. H1 mean fast food more than mean restaurant. Step 2, state the alpha, which is 0.10. Step 3, use T distribution. Step 4, find the S bar 1 and S bar 2, which is 142.50 and 130.2 relatively. S1 equal to 12.24, S2 equal to 15.79. So next, we use the formula S power of 2p n1 minus 1 s power of 2 plus n2 minus 1 s power of 2 divided by n1 by n1 plus n2 minus 2. So we get 204.0939. And next, we use the T formula, which is x bar 1 minus x bar 2 divide the square root s power of 2p 1 divide n1 plus 1 divide n2, and we get the answer 1.55. And lastly, step 5, 1.55 is inside the rejection area. H0 is rejected. We can conclude that the mean salary for fast food workers are greater than the restaurant workers. So the p-value is between 0.05 and 0.1.
Now on to the second last question, which is question 3A. So the question is about to compare the differences computed between post-training survey score minus pre-training survey score. So 7 customers were randomly selected and completed both surveys. We can see that the question is a dependent sample because the samples are paired and related to each other. And for the answer, step 1 is determine the H null and H1. H1 will be mu is larger than 0 because the question asks what is the decision regarding hypothesis that the training was effective in improving customer relationships. So the keyword is improving or improve, so that the mu will be larger than 0. And automatically, the H null will be mu is less than or equal to 0. And step 2, we determine the alpha value, which is given by the question, which is alpha equals to 0.05 significance level. Step 3, we use t distribution because these are the samples. And step 4, we determine the critical value, which is 1.943. How do we find the critical value? Is by finding the degree of freedom, which is n minus 1, which is sample minus 1. And we find it in the column of the critical value, which is significance level, which is 0.05 on one tail test. So by finding both value, we can find the exact critical value, which is 1.943. So reject H null if calculated T is larger than 1.943. Do not reject H null if calculated T is less than or equals to 1.943. Now, after we had found the critical value for this particular question, we can sketch the normal distribution diagram. So our critical value is 1.943, will be on the right hand side of the diagram. And after we have done the diagram, we can determine the area of rejection, which is on the right side of the critical value. And then we calculate the t value, which is by this particular question, we use the formula which is d bar divided by sample standard deviation per square root of n. So what is d bar and how we calculate the d bar? D bar is the mean differences of the samples. So how we calculate it is by subtract or minus each pair of these samples, which is post-training survey score for this particular question, minus pre-training survey score. So each pair will be minus each other and will be divided by the total amount of sample, which is 7. So for this question, the value of d bar is 2. And then after we calculate it, we can uh, put all the value we had found or we had calculated, which is 2, divide by 2.082 per square root of 7. And then we calculate the formula and we will get the answer, which is 2.541. After we have done step 4, we will be moving to the step 5, which is the conclusion. So 2.451 is inside the rejection area. because the calculated T is larger than the critical value. So H0 is rejected. We can conclude that the training was effective in improving customer relationships. Now, moving to the last question, which is question 3B. So the question is about 8 intersections were chosen at random and the lights at those intersections were modified. The numbers of minor accidents during a 6-month period before and after the modifications were given by the question. So the question is the same as previous one because it is a dependent sample because it is paired and related to each other. And then so the all the steps are the same as the previous question. For step one, the H1 will be mu is less than 0 because the keyword is reduced. Is it reasonable to conclude that the modification reduced the number of traffic accidents? So the keyword is reduced, and automatically the mu will be less than 0. And national automatically will be mu is more than or equals to 0. And then step two, alpha, we determine the alpha value that is given by the question, which is 0.01 significance level. And step three, use the distribution. And step four, reject hash null if calculated t is less than the minus 2.998. Do not reject hash null if calculated t is more than or equals to minus 2.998. So how to get the critical value is the method is the same as previous question, or the method is the same for any other question, which is we determine the degree of freedom and the significance level on one tail test. Now, after we had found the critical value for this particular question, we can sketch the normal distribution diagram. So the critical value, which is minus 2.998, will be on the left hand side of the normal distribution diagram. And we can determine the area of rejection, which is the left side of the critical value. After that, we will calculate the t value, which is we're using the formula the same as the previous question, which is t bar divide by sample standard deviation per square root of n. So we calculate the value of d bar, we will get the answer, which is minus 2.5. And we calculate the standard deviation, which is 2.93. And the sample, which is 8 samples. The total sample, which is 8. And we will key in all the information in the formula. We will get the minus 2.5 divided by 2.93 per square root of 8. After that, calculate it, and the answer will be negative 2 minus 2.41. So after we complete step 4, we will moving to the last step, which is step 5. Minus 2.51 is outside the rejection area. So the H null is not rejected. We can conclude that the modification did not reduce the number of accidents.